Hello everybody, welcome to Dr.K.Liu Math channel. This question is also we want to use Riemann sum in the definite integration to find a definite integration. Okay, for the first part, we have to use this formula. Therefore, we have to prove this formula first for this function. I first prove this by using the summation sign. Okay, I change this to move the denominator of right hand side to the left hand side. Consider sine 1 over n times pi times summation r from 1 to n cosine r pi. Consider this one. And by the sine cosine sum to product, sine times cosine b, which is equal to 1 over 2 sine a plus b minus sine b minus a. Therefore, the sum can be changed to summation r from 1 to n sine pi over n cosine r pi over n, and then 1 over 2 summation r from 1 to n sine sum r plus 1 over n pi and minus sine r minus 1 n pi. Okay, I list all the terms outside for equal to 1, which is sine 2 pi over n minus sine 0 plus sine 3 pi over n minus sine pi over n plus sine 4 pi over n minus sine 2 pi over n. Okay, I observed that the pattern is occurred. The pattern is occurred because these two terms can be cancelled. Only leave this term. If I write one more terms, I also observe that these two terms cancels. Only leave the last two terms. Okay, that means for the last, I only write the last two terms. The last term is sine n pi over n minus sine n minus 2 over n pi, and then plus sine n plus 1 over n pi. And by the pattern recognition, that all those terms are cancelled. Only left this one and this one. Therefore, the final result is, okay, I write here 1 over 2. This is 0. This term negative sine pi over n, and also plus this also sine pi is equal to 0, and plus this term. This term is 1 over n pi. That is the result it deserved. Okay, then for part B, by the Riemann sum of this integration 0 to pi cosine x, I first change to the x to the pi y, then dy, then dx equal to pi dy. And when x equal to 0, Yes, x equal to 0, y equal to 0, x equal to pi, y equal to 1. Then I change this one to 0 to 1, and 1 over pi. Oh, no, not 1 over pi. Pi cosine pi y dy. And separate all those terms into, from 0 to 1, separate to 1 over n, 1 over n. Evenly separates into n brackets, and each bracket is 1 over n. And for the first part, pi factorize in outside 1 over n times the first one. First one is this one, cosine pi over n. And then for the second, 1 over n cosine 2 pi over n. And for the third rectangle is 1 over n times cosine 3 pi over n. And then for the last one, oh, I forgot the limit here. Plus 1 over n cosine n pi over n. And factorize n outside. Here is cosine pi over n plus cosine 2 pi over n. And then cosine n pi over n. By the formula in part A, this is sine pi over n here. Sine 1 plus 1 over n pi minus sine pi over n. Take limit here. And the pi actually here is a declaration only. Only effect affect the limit is only the value of n. And we can observe that the denominator is, let me see, which is 0. This tend to 0, this tend to 0. And for the denominator, I only check the denominator only. Here, limit n tends to infinity, n times n sine pi over n. And then I use this one by L'Hospital's rule. By the L'Hospital's rule, that is pi over n squared cosine pi over n. That this is numerator, and the denominator is this one. Oh, so like this n squared cancels and negative also cancels. The limit, this should be equal to pi. Therefore, the denominator is 10 to pi. That numerator is 10 to 0. That's the overall, the limit is 10 to 0. That is by the Riemann sum, this integration of cosine x dx from 0 to pi is equal to 0. That's so nice problem. Okay, I hope guys can enjoy this video, and also I hope that you can find this video is useful. If you have any question, you can tell me, and hope I can do more for you. Okay, finally, please subscribe my channel. Bye bye.